So welcome, good day, and I'm looking. I can see that not many of them, not many of you came to look at Aviasales and with Yandex. My topic is much lighter, not that, so to say, research intense. But the question is anybody of you buying tickets, flying tickets, the internet? Is anyone of you using it? Is buying tickets through Aviasales? So if you don't like Aviasales service, but you use competitors, I'm talking about not about the OTA, but about the search engines. So the Kiwi is our partner, it's not a competitor of ours. So in my talk I wanna tell you about our engine, our search engine. I don't see my show notes, so I'll try to give a talk without them. I will tell you about our search engine. I'll tell you about what is a meta search engine, which tasks we have to work on. I will tell you about the configuration. I'll tell you a couple words about the deployment and monitoring. Nothing new, nothing complex, but maybe you'll hear something interesting for you. So Aviasales is a meta search engine for plane tickets. What is the principle? So let's use. We are honest with users. We show the final price to the tickets. Means we took into account all the margins, all the taxations, anything else. If any online agency charges, if you use a credit card to pay, we also give high. We also include in the price. So sometimes the Aviasales price is higher than with competitors. Also, we show all the relevant actual results. We see this update button 15 minutes after the search at your mobile device or our website. You will see this button update. It shows that the search results are outdated. We do not cache any results. We use cache only for low price calendar, so you could approximate what's going to be the cost of your flight. The actual prices you will see after the search. And also we try to work as effective as possible. This is how our search engine has been developed at one of the early stages. And the GNU grep also 10 years ago answered why GNU grep is so fast. He said that your software should be so fast because since it's doing nothing, thus it tends to be very effective. So now let's talk about search engines in numbers. We process 2 million requests every day, about 2.5 to 25,000 requests per minute, and with about 5,000 tickets we search. We show. With each request, we send about 200 requests to our partners. We receive about up to 600 megabytes of raw data to be processed in 40 seconds. 40 seconds is a full time of search. After that, the search should be completed, and the user should get information about the ticket. Basically, now we managed to answer that fast that we are ready to show you the results in about 2 seconds after the search has been launched. But It's not that many partners are answers it fast. So we have so-called pre-roll. So first, search results are provided in 5-10 seconds after several offers were found. So the user will feel that he has a choice. And our tests show that majority of users wait for the end of search to see the relevant results. What's inside? We have so-called Yasen inside. It's very simple acronym, many uses, yet another search engine. So what it has inside? Nothing complex. Servers, 16 instances of application per server, and it has a very newly launched process, has a very small memory footprint, about 60 megabytes initially. So that's how the search goes. Let's see, we choose data. For instance, we want to fly from Moscow to Phuket, and we send such a simple request like JSON to our server. Let's look at the story of the search. First we come to the balancer machine. You know, it's hub proxy. Everybody knows it, and many of you use it for sure. Hub proxy actually finds the best B, or the least loaded B. We have about 1028 Bs, 16 at each of the servers, and then what's going on? What's next? And then the magic. What is the B? B, it serves all HTTP endpoints. Inside it has Tornado, and it sends HTTP requests to so-called chains, which I'm going to tell you a bit about later. What B does? It receives requests, sends requests to partners, processes data. It does not write anything to external storage. It's only to local queue to be as rapid as possible and as asynchronous as possible. And I'll tell you a bit about our chains. So Lena in the previous talk talked about the description of their features. We have something similar. So a chain, it's like in a sailor, where if you use tasks, sequential tasks, so the chain is something similar. So we set quite simple units, which on inflow receive search request, which expands. The more units we have, the more units we have, and then we have search results. So for better to understand what a sequential chain is, just look here. For instance, we have some incoming data with 0, and we have two similar units which can just sum up data. First is configured that to the incoming parameter it will add 1, and the second is configured it will add 5. So at the end we will have 6. Nothing complicated. And the second type of chains, so-called parallel chains, we are trying to work parallel, so because it should be done in parallel. And the parallel chain, it might consist of several units or from sequential chains. And at the end we'll have just a set or the list of results. So it's hard to work without show notes. So units, they should be very simple, because the main requirement to the system was that business logic could be ordered even by managers, meaning they should set what is incoming data, how they could be expended, and what should be done, what should be done for the things to work fine. Units should be independent, so we should be able to test them either within the system and separately. So meaning, if in our operational implementation, if we feed the unit with some incoming data, we will, in any case, we'll have some, so say, relevant result. So throttle unit. It decides whether there should be request sent to the partner depending on the config value. If the config value is below 0 or below 1, then with some probability we will not send the request to the partner because, for instance, our partner might be problematic at the high load. We know that it can take 50,000 requests per hour, but 100,000 it will not be able to process. So we'll send only 50% of the traffic to that partner. So this is how our current unit looks like. We configure it with HTTP method setConfig. We, for instance, we take this currency converter unit. Here we feed as entry data. The currency exchange rates are given here, and the call we provide the ticket price. We show all the prices in rubles, but here we show all the prices in rubles, but we feed the price as US dollars, and then the converter converts the price in rubles. So all the units in our search engine, they have 3 endpoints. I mean, to set config, call, and get config. I mean, to see the current status of the config. Which types of units we have? We have rulers to configure whether we need to send a request to the partner, meaning it should be included the set of gates. We also have gates. So send requests of data and then obtain the data from them. And we have extenders, which are different dictionaries to obtain particular data on tickets. Or specific data on tickets. Also, we have filters to validate gate responses, and we also to filter out tickets which are outside of our business logic or should be showed at some point of time. For instance, some air companies, they do prohibit meta search engines. They prohibit meta search engines to show their tickets. So some American companies, they do it, but those are present in the global distribution systems, and we should somehow filter out from the partner responses. We should filter out such companies prohibiting that. And also we have various senders sending the results to the local queue, and then this data are transferred into the external storages. So this is graphic, this image does look very nice, but it shows how the request works. First, we have request coming in parallel to several gates. Then once all the gates have been pulled, I mean, all the gates are pulled in parallel, and once the results are ready, the results are merged and sent to local storage. And from the storage, we can obtain the results using our clients. For instance, when you see how the data is produced in real time, you can't see it quite nice on screen. We're trying to be almost real time or near real time. As I told you, we are ready to give some results in 2 seconds after the search has been started, and quite a lot of data is produced. Up to 20 megabytes of uncompressed data are given to the client after this search completion. And is another entity of our local engine. It works on the local queues, moving the data from local queues to external storages. Couple of words about the configuration. So the meta search is a rather complex topic. Each moment of time should understand which partners and which parameters could be polled. Some of the partners could be broken. Some of the partners could provide wrong price for air companies or regarding some directions, and so we have to do configuration properly and appropriately and timely. So configuration. Every non-tech guide should be able to configure the system behavior, meaning configuration files and configuration rules. And for that, we need to use quite simple config format, and the system to manage configs should be error-prone, should be, so to say, foolproof. For that, we have so-called centipedes. Centipede is a simple VI interface for configs. It has JSON format. It loads and saves files, and we can also manage chain constructions. I mean, we can add up or remove units in runtime. This is the typical gate config. It's just a JSON file within the search engine. It's just addicted. Even the supporter can add some fields here. For instance, this part is responsible for partner tech support, and out of there are generated content pages, and our users could find out information where they could find the support, how they could obtain support if there are any issues. Here is about the error control. If there is a human error here, then we're trying to we're asked to change some or correct some typical errors. We're trying not to save those errors. So how to save those configs? So each node has an instance of so-called watcher. It's a watcher, which it's a service watching changes of the file system using iNotify and distributes configuration changes to local bees at the current node. And then we, from master node, we quite simply and cheaply can distribute them using rsync. All changes files are distributed using rsync. So the event in the file system of the nodes happens, and also watcher then works there. About the deployment. A very important moment, and it's in the kind of a pain in the back. You know, several years ago, system was in such a status. The deploy for 8 servers took about 2 hours. So it was quite a manual procedure. And why? We can't lose any of the search requests. That's why we had to wait at each node when at each node each bee would complete its search, and after that we killed that bee and monitor then reset this bee. Then we need to be very precious resource. Command started to work to fight for the changes to get into the deploy, and there was an issue in the commands. The teams to be less mobile. We migrated to Docker. We migrated our servers into the containers since they're quite independent, and we added simple orchestration, which we created we had a bash script orchestration, quite simple, and for the servers we started to deploy them in less than 10 minutes, and now developers are very happy because they could deploy up to 6 times a day or even more often. And what is the future of our deploy? Well, we configure pipelines using Jenkins, and we introduced orchestration by Kubernetes, but for that we needed to hire a whole DevOps. If you don't have a DevOps, you should you should obtain those guys. Quite useful. It's the same for the service in less than 10 minutes. Yes, the same. Up to 6 deploys a day. Yes, but now with Kubernetes and CI and CD. So a couple of words about the monitoring, just a little bit. We have a distributed team. The search engine is worked on by several teams. It's integration team, it's my team, and the core developer team. And monitoring involves different people at different levels. Just due to that, we don't have a single point of responsibility. Every team monitors its own, so to say, story, and that's why every team uses its own stacks. Sysadmins, they use Zabbix to monitor service. It's quite great story for them. Core team for performance using Datadog. Any one of you using Datadog? Oh, sounds interesting. And our team, integration team, uses so-called tick stack. It's an influx, capacitor, and telegraph. So maybe any one of you saw it with time series all the time. Well, cool, one person. So we're using tick stack. It provides more flexible configuration for a complex rule for monitoring, to monitor our partners, to monitor our business features, but not only apps for CPU usage and memory. And that is my clumsy talk. The set of my clumsy talk without show notes. And I'll be glad to answer all your questions if you got something in your head or in your, so to say, pocket. Thank you for a great talk. I have quite a primitive question. Tell me please, aggregators like Aviasales, are they involved somehow in price formation? Because I noticed several times that with different combinations of absolutely independent companies, the final price of the ticket could be really different. Well, Aviasales is not involved in the price production formation, though we are request from our partners. They would provide the lowest price to us and would provide us with upsales. They wouldn't add up upsales, I mean insurance and others by default. The ticket search is a very complex area with lots of bugs and stuff. Like they have lots of bugs coming from aggregators and others. So there's also a question: where is it cheaper to buy a ticket? At the online travel agency, at the air company, or at the cashier? And every time it could be a different story. You could search at the Aviasales as an entry point to see some companies fly to the area you would like to, and to try then to search those other companies. And through the combination of various factors, at a different point of time, there could be different prices. But so Aviasales is not involved in is not involved in the price formation. Thanks for a great talk. My question is the following. Why don't you want to cache even a bit? Because you said you don't use it at all, but for instance, such popular areas like Moscow to St. Petersburg, like in 5 minutes cache, and in popular time periods, you would know that for each user, the bit is coming back and forth, you're producing all the same data from the same partners. So, well, actually we're coming to such caching solutions, but we cannot cache it because there are too many of cache options. We should cache for each currency. Each local response for each market, for each direction, for combination of dates. There are lots of too many of caching variants. And for popular areas, we test caching. If we show some good conversion results, maybe we'd use it more aggressively. Once there are so many caching variants, we are trying to be very, very careful about that, but using that. Thanks a lot about for talk. So tell me, please, you said quite in detail about how you obtain from your partners some prices for some flights. You provide the tickets, but Aviasales are usually used for a bit different purpose. I mean, searching for some combinations on, let's say, on how to buy such set of tickets to make the cheapest sum. So how deep you go up into that graph when you search for a way, when you're searching for a route? Because I noticed when using Aviasales, because sometimes the manual search sometimes quite often turns to be much more cheaper. So we don't go too deep into the graph. This is what our partners do. We just tell to the partners, this user wants to go there, these are the dates, show us the cheapest solution, but it's always business. Why in two different searches you find cheaper tickets? Well, agencies, they have business rules. Let's say this way. As in air industry has less and less money. It's hard for people to earn money. So with air tickets, they do not earn much. This margin, this markup from air companies and travel agents, this markup is very low, is minimal. With some air companies and travel agents, when selling just a ticket, they earn nothing. They can earn only through upsales, and then it switches on the combination of business rules, which makes them to earn more and not to lose money, because you could return the tickets and so on. So, for instance, when you buy two different routes individually, you take this risk on yourself. When you buy everything as a set, the risk is taken by the online travel agency or air company, and thus the cost of the ticket is reflects a bit this risk. Tell me about the air tickets. It's a very interesting niche topic, really. That's okay. Now my questions, then thank you, thanks a lot. So you should select the person with the best question. Oh yeah. It was a good question about the caching. Because every new developer coming to the Aviasales saying, why we don't cache? He trying at the weekend to work on that, and after the weekend says, okay, now it's clear why. So let's give the price to this person to the question about the caching. And thank you, thanks a lot. So there's no more talks here in this room for today. We have a panel discussion, which you're going to have as the room next door, and then we'll have an after party. Thank you.